Hello, my name is Luigi Vanfretti. I'm an associate professor at Rensselaer Polytechnic Institute. And this user presentation is about my experience in teaching a course on modeling and simulation for CPS using Modelica and FMI technologies and some hands-on laboratories. So this is an overview of my presentation. First, I'll just give a little bit of a motivation. What are CPS? What are the industry needs and the challenges? My own needs. Then I'll give an overview of the course. One of the major activities was to roll out some labs to develop them also, and some future conclusions that that I can offer. So CPS are technologies that interact how people work with engineering systems, how they interact with them. Basically, the new CPS technologies are going to really transform the way that people interact with information. So it's more or less the idea of going from the internet information to the Internet of Things. The view of CPS and CPS in general help drive innovation and competition. One of the major areas is aeronautics and building design, energy. We're starting to use it for electrical powered rigs. And the idea is the CPS will enable capability, dependability, scalability of systems, and they will help in improving the safety security of critical systems. And I work mostly in the electrical power area and electrical grids, and really the view of CPS can really help shape the idea of smart grids and now what is being called the digital grid. So there are many areas in CPS. You can go to this website, cyberphysicalsystems.org, and see this very interesting map. So I cannot talk about everything, but trying to give an idea, CPS are engineered systems that are built from and depend on the integration of computation and physical components that interact with humans. So what I like to say is that the physical components or physical system follow the laws of nature, so mechanical systems, HVAC, thermal, all of that. And cyber components or cyber systems follow rules of algorithms. And that's computation, how a computer system will perform calculations, how communication networks send around the signals. So CPS has many areas and fields, and it's impossible to really cover all of this in a course. So what I try to do from this picture over here is to cover some aspects on design tools, design methodologies, and modeling, basically. And the Modelica language really fits well for this purpose. Some of the challenges that industry see, this is a picture from different collection of slides that I found from Boeing. And it's in the aerospace area that you're going to see perhaps among the best examples of CPS development other than the vehicle, the automotive area. So in aerospace systems, you will have the airplane, you have the airplane operation, traffic operation, I mean, an array of different systems interacting with each other. And Boeing has really led the way on applying model-based tools and methods using software and so on. So the idea of this course was really to cater to these kind of challenges. How do we help students get acquainted with these topics? And to be not only ready for industry, but also aligned with needs that they need to meet. Especially in the case of Boeing, that as some of you might know, that they signed a 30-year contract with 3ds Experience with Dassault. And if you look at the needs that they have, they're looking for people that has experience with modeling and simulation, discrete time event simulation frameworks. If you look at the 3ds Experience, is basically trying to provide this end-to-end collaboration, design engineering analysis, and so on. And in that platform, you have the system analysis area, which is basically Modelica / Daimola. So these are some of the skills that students will need to work with these kind of platforms as they go in the industry. And Modelica is a key part for that. Not only to be able to develop system models, but also to capture intellectual property and reuse it, along with all of the other tasks that we're used to do in complex engineering tasks. Just not to only talk about the example of Boeing, if you search on LinkedIn, periodically, you'll find an array of different companies that are looking for this sort of Modelica, or I search for Daimola also. I'm not promoting Daimola only, but it's just to give you an idea of how the new technologies, for example, Tesla is looking for people with this sort of know-how. And well, this is also nice for me because I can tell the students, you want to work in cool companies, you got to learn Modelic. Take my class. And finally, the last need is my own. So I work in what I call electrified systems now. So not only power grids, but now I'm working in aerospace and hopefully other areas soon. So we need to develop real-time sort of measurements, networking, analytics. And to be able to do that, we rely a lot on real-time hardware-in-the-loop simulation. So here you have some of the 3 different real-time simulation platforms that I have. And I basically need students to really understand modeling and simulation and be really skilled with it. So yeah, this is one of the needs is for me to be able to do my research, such as in these 2 projects, like the Cheetah project, where we're trying to model and simulate a new hybrid electric aircraft, and a new project that is starting with a consortium funded by DOE, where we're doing multi-domain modeling of electrical network and thermal networks. So as we go and interface more things together, being able for my students to be able to do their job in the projects, I need to teach the class because nobody else will do it. So I had to design this course, and yeah, let's talk about the course now. So in order to get the course to the traditional curriculum development process at the university, one of the things that was really useful was to find this report from 2016 from all these national academies of science, engineering, and so on. And they highlighted the importance of different foundations, but they specified one, and that is the need for modeling of heterogeneous dynamic systems, integrated control, computation, and communication. So this was really laid out for me in the report, and I needed to bring it forward to the two committees, the undergraduate program committee and the graduate students program committee, so that I can show them, hey, there is a big need on this. Industry also needs it, and I think I should be able to develop a course on that and fill this gap. So the ambition is really to remember the map that I showed you at the beginning. Well, the idea was that I will try to develop a course that the undergraduate level will cover all of these aspects, and at the graduate level will cover more of feedback, well, more of control, because that's are things that are needed for my research and I enjoy. We're not there yet. I will show you what I have. But what I've been able to do is at least cover some aspects of what you see here. What the course enables is to be able to do modeling, an analysis of hybrids, heterogeneous systems, of the physical world, of computation, and not yet, but almost there, including synchronous. So not just continuous and discrete, but hopefully I can do synchronous. And we are introducing real-time simulation, as you will see. So here is the course activities from the lecture point of view. So this is what I do in the class. The course is divided in two major portions. The first is lectures 1 through 9, which basically is teaching the Modelica language, teaching it to build models using the standard libraries, using equations, and so on. And once that portion is completed, the students have their first lab where they actually have to model a cyber-physical system and verify it against measurements. And I will talk about the labs later. So that lab kind of puts a capstone on the first part of the class. The second part of the class is what do you need to learn to effectively use Modelica specifically. So we talk about reusable modeling, model architectures, templates, model variables through data management, records. How do you handle discontinuous systems? How do you integrate with other tools? The FMI standard, real-time simulation, and how do you use the models for control? So linearization and simple things like that. And that really helps for the students to see what they will need to achieve when they do their project, which is the major way to assess the course. So the lab 2 is about real-time hardware-in-the-loop simulation. It introduces the basics, and you see here the students doing the lab basically with the robotic arm. And here's a sample lecture where I'm teaching partial models and inherence. So these are skills like from the context of my research projects. They're all useful in developing an aircraft power system, but in reality will be any system, right? Here's some more sample lectures. The classic explanation of potential flow variables, how to deal with the state events. Templates, data management, real-time simulation, and that's perhaps one of my favorite lectures. Okay, so that's basically what I do in the class. What the students do is that they need to do workshops. So they're provided with a homework assignment that looks like this. and they basically have to follow what is written there and try to solve it for themselves. It's not really a tutorial because they don't have me or anybody next to them to do it. So you can see this more like guided exploration. So do this. What do you find out? Answer. And sometimes they get stuck. So it's an interesting way of trying to do typical university education, let's say. This is one of the solutions from one of the students on coupling Daimola with Python. This is one of the more later examples. But you can see here, what the students prepare in the report. So they're basically working hands-on with the language, with the tools, and with the concepts. It's not a theoretical class. It's a hands-on class also. Yeah, so I said that the students do two things. They do the homeworks, they do the labs, so three, and the major part of their assessment is the course project. Here is one of my favorite examples of the class, Christian Canham. He modeled the rocket landing of one of the retrograde rocket landing from SpaceX. And what you can see here is that he even got data. He did an internship at SpaceX and managed to get some data to compare his model to the simulation, and even built visualization for it. So I think the projects really tell you how much the students learn and what they can achieve with these new skills. And Christian is now working for Boeing, so I hope he gets to continue doing these things. And I think this project is amazing, right? Because if you look at the number of things he had to do to develop models, and yeah, he did a great job. Here is another project that is pretty amazing. I taught this in Kaust in Saudi Arabia. And basically, Jose developed a whole library for simulating, modeling and simulating light wave energy and data transmissions. And you can see that he even developed the ability to do hardware-in-the-loop modeling and simulation. So here is the laser, and when it detects the target, it stops. So it's a pretty nice project. One of the things that I decided to do after this second time I taught the course, was to, okay, how do I integrate my current projects into the classroom? Is it even possible, right? So what we decided is, with the Cheetah project, we identified different subsystems that we want to include, and we provided the students with an assignment. So based on this assignment, you write a proposal, and then based on the proposal, we review it, and then they will do their project. So this was very exciting. There's a great number of these projects that were very nice, very successful. The ones that are the coolest, let's say, this is not an electric plane, but one aspect of the Cheetah project was to bring in students to get involved with topics that are around what we're doing in the project or in the aeronautical aerospace field. So Jake took a drone model that we have been developing for a while, and he did basically a visualization with it. So he learned how to use the Modelica visualization library to couple it to the joystick and couple it to the VR environment, and created some nice scenarios. And I think this is a great example how we could use these tools for early design interaction. So I hope I can keep working on these kind of things. Another pretty cool project that Jordan did was to do modeling of the controls using the classical continuous time approach, discrete time approach, and the synchronous library. So this was a really, really nice project that gave us some good understanding of how are we going to model controls for the Cheetah project, for example. So definitely we have to use synchronous control models because the simulation efficiency goes through the roof. Okay, so something about the labs. The labs were developed and rolled out thanks to Boeing's. Boeing gave me a small grant for developing the course. So I used it to develop these labs. So really the idea is that they apply the course learnings to an actual CPS system. They build it. So we use this we use the Arduino starter kit. They build it in prototype, in actual physical, and they build a digital twin, a model using the Modelica Arduino library. So they have to make the prototype, they have to take measurements, they have to build a model, and then they have to compare the model to their measurements. And what's the difference? As you know, the models are not reality, so of course they found some differences. So yeah, before the lab, basically they're asked to put the hardware prototype together. In RPI, they have been using this analog discovery board, so they already have their own measurement system. So the Arduino starter kit is quite cheap, so they can build their circuit and take the measurements before class. During class, I basically teach them how to build the same project in Daimola using the Modelica Arduino library. And after the lab, they get a mini project assigned. So they get one of the projects from the book that comes from the from the Arduino starter kit. So this shows you what they have to do during the class. How to put the model together, how to get the code that runs on the Arduino and put it on the Daimola model, and how to take measurements, how to compare. And this shows you one of the assignments of one of the students, the experiments that they're doing, and a little video and their comparisons. Here's another example. This was a really nice one. So it's a zoetrope. You know, you can see the little flower moving around, and the Modelica model. And you see he actually tried to replicate the animation. So this was a very nice and successful lab, let's say. The second lab is on real-time simulation, as I mentioned before. So I divided in three parts. The idea is that they get a first hands-on experience in real-time simulation, which normally is super expensive. But thanks to having the ability to do this with the Modelica Arduino library, we can acquire measurements from a part of the system that is outside of the computer, and the other part is inside. So they learn to use these libraries to integrate hardware with software. They learn a little bit about the Firmata protocol, and they learn about how to select solvers and all these things. So they have to build a hardware prototype. They have to interface the model, its models of controls and logics with the actual physical system. To acquire the data, analyze the performance of the controls, and to extend them. So here is the first one is very simple. They just have to dim a light from the computer, right? So we inject a signal and we make it move around, and well, that's pretty much it. The second experiment is basically to gather measurements and trigger an alarm about, inside of the Daimola. So we will have this circuit. We touch a temperature sensor. When we pass the threshold, this light bulb, this LED turns on, and it also turns on inside of the software, basically. So here we have the trigger threshold, and the output signal when the threshold has reached is sent outside. So here we have a piece of the model and system in software and one in the hardware. In the hardware, we have the sensor and the physical alarm. And in the software, we have the logic and the virtual alarm. So it's very simple, but it's very fun, I think. And the last one is basically to control this braccio arm. In Italian is braccio, which is built for the Arduino. So this is an interesting project because you can start moving one of the motors and you'll get it to do it. But this is a terribly unstable system. So when you try to move all of them, it's very difficult. So I basically teach them how to do the first one, and then they have to build a whole interface to move all of them and see what happens, how reactive, responsive, what happens with it, right? I plan in the future to try to use feedback control, but we're not there yet. But I think it's a nice exercise to start. Okay, so here's my conclusions of future work. The next steps, we're going to continue developing the VR-based early design interaction for UAVs. So my idea is, if I can, get a few more virtual reality headsets and have the students interact with the design and improve it after they interact with it. To do this, I will need to get licenses from the Modelica Visualization Library. So I need to evaluate how to go about that. The second thing that I want to do is to integrate the full model-based system engineering approach. I will do that through a lab and a lecture. So it's not going to be a whole course about MVC, but there's already some resources available from Dassault using the 3ds experience platform. So we've bought this Quanser Aereo system, and they have a number of resources to carry out model-based systems engineering labs. So I have a student looking into it, and I hope we can figure out we can use it. Of course, we have to solve the issue of having access to 3ds licenses. We have them thanks to Dassault, but I don't know if I can make it happen for 20 students, right? The computers that they have might not be good enough for 3ds for all the CAD stuff. I will have to reuse or redevelop depending on how complex the current materials are. And I have to do a test run before I put it into the course. So I'm working towards this. Hopefully we can put it together. So yeah, the course has been offered in 3 occasions, twice at RPI, fall 2018, fall 2019, and summer 2019 in Kaust in Saudi Arabia. I'm hoping to offer it next spring. The student feedback is really encouraging. I think there's good reception. Here are some examples of feedback that the students gave. At the Hands-on Lab 1, I think the feedback was really fun and nice to listen to, but a couple of the students couldn't believe how hard it was to calibrate the models to their simple experiments. And these are not so complex to, let's say, a power plant or a plane. So it really gave them the feel of, modeling and simulation is not something that you can do overnight. You really need to learn to do things well. The second lab showed the trial run that I did in Saudi in cows. We built the robot arm during the lab. That was not a good idea. So when I run it here the second time, I had a technician help me assemble them so that students wouldn't break them that easily. Also, it takes like time. And they really had fun playing with the robot, right? Once they got everything to work, it was time for fun. And so some students actually started making them fight with each other. So it's fun. I think the lab activities really helped the students appreciate what they were learning on the Modelica side, and it was better for them to understand the utility of the models, which is the role of the project. But the project, they are more stressed because that's their 60% of their grade, more or less. So in future work, what I would like to do and why I wanted to have this user presentation, it was because I want to engage with industry to develop other course projects. And maybe if you work in a company and you have an idea for a project, but you don't have time to do it, but you have an hour a week to guide a student, let me know. Let's work together. We'll get a student working for you with you to do a nice project, and maybe you can find somebody that you would like to work with and recruit him. Okay, so thank you very much for your attention. Yeah, please reach out if you have any feedback or questions. Thank you very much, and I hope you enjoyed the presentation.